Cette conférence va maintenant être enregistrée.
Hello everyone, I let everybody arrive, some people are still meeting, but just for a quick introduction to this webinar today. So first I would like to thank our speakers from KOBELCO ECO-SOLUTIONS and all their team for accepting our invitation. We are all very eager to know more about your activities, your experience in Japan, to learn what could be interesting for us to do in France. By learning from your experience. Also, special thanks to Yannick Ferrière, who made it possible to meet you. So thank you, Yannick. And finally, thanks to all the participants today. So I will let our speakers present KOBELCO, their activities and some references, and then we'll take time to exchange, to ask questions, etc. So you can put your questions into the chat section, sorry, on the right of your screen. You can ask your questions whether in French or English, and I will translate it if it's in French. Also, you can wait for the end of the presentation, the questions and answer session, to directly ask your questions to our speakers. And last point, this webinar will be recorded and the video will be available on the YouTube channel of our association and on our website. And I think that's all for me. And Naomi, you can speak. Thanks again for accepting to be here today.
Good morning. Bonjour, can you hear me?
Okay. I hear you well.
Okay, I'll start. I am Naomi Kubota from the London office of KOBELCO ECO-SOLUTIONS. First of all, thank you very much for attending to the webinar today. Special thanks to Pyrogazéification Club to giving us this opportunity, Madeline to organize everything, and Yannick-san from SG Energies who has introduced us to the club for today, and for being enhancing and passionate for the gasification technology. We are very happy to be involved. Today, we will talk about KOBELCO's waste management technology. There will be myself to give you a quick explanation of a company for the big picture. After that, we will follow by Mr. Nii, who is a senior expert from the Waste Treatment System Engineering Division. He will join us from Japan today. Now I will move on. Today there will be three parts in the presentation. First, a profile, then our technology, lastly, our reference project, which will be Sennan Waste to Energy Plant in Japan. I will start off with our brief company profile. We are called KOBELCO ECO-SOLUTIONS. We'll call us KOBELCO or KES hereinafter, is a steel subsidiary of Kobe Steel, one of the major steel company in Japan. Kobe Steel has more than 100 years of history, founded in 1905, with 250 group companies and more than 40,000 staff altogether. There are three main core business in Kobe Steel. First, the material segment consists of iron, steel, welding, and aluminium and copper. Secondly is the machinery segment consisting of engineering, construction machinery, and machinery. Thirdly is our electric power segment, and we have power plants currently in operation. We, KES, is in the engineering scope within the Kobe Steel Group. Kobe ECO-Solution was founded in 1954 and now expanded to that net sales just above 800 million euros, and we have about 3,000 staff altogether. Our main business is so-called environment plants. Our core business are water treatment plants. I will talk a little more later. Environmental restoration and recycling, such as PCB detoxification. Process equipment, we do glass line reactor and hydrogen related business. Environmental analysis and cooling power. Lastly is a focus, which is waste treatment and recycling. We have a couple of technology for waste treatment. We have 8 incineration plants since 1982. Also, next we have 40 plants of gasification and combustion since 1982 as well. And lastly, the technology we will be introducing today, which is the fluidized bed, gasification and melting furnace plants, which we currently have 22, the first plant starting in year 2000. This is just to focus a little more to show our water and waste technologies from top to bottom. Regarding to water treatments, we have water purification plants, including such as tap water, sewage treatment plants for wastewater from large to small scale. This includes industrial water. Then we have sludge treatment plants for the residues of the wastewater treatments. This sewage sludge can be fed to a waste to energy plant, which will be explained later. Most of our business has been inside Japan for decades. However, since around 10 years ago, we have started to expand overseas as outside Japan. Mainly from Southeast Asia, we have offices in Vietnam, Cambodia, Myanmar, and a project office in Thailand. Also, we have 2 waste treatment plants by licensing in South Korea. And the most recent office we opened in 2019 is in London in order to expand our business in Europe. These are the list of all the fluidized beds and melting furnace plants in Japan. There are other companies.
Sorry, Naomi, please just turn off your mics when you don't speak.
Okay.
Sorry about that, Naomi.
Oh, it's okay. I'm not exactly sure.
You can go on.
Okay. There are other companies that supplies gasification plants, but we have been most successful. Our first plant was completed in year 2000. The blue circle in north of Japan, completed in year 2000. Since then, we have adding more to the map. Excuse me. The biggest plant is in Japan, is in the green circle called Sagamihara plant. We operate 3 lines altogether, 525 tons per day. Today, we will focus on the Sennan plant, which is in red circle. This plant also treats waste, dugout waste from landfill. This will be explained later on as well. One of the features that differs our gasification technology from others is that we do not use coal or fossil fuels for everyday operation. Outside Japan, we have plants in Thailand and 2 plants by license in Korea. And lastly, and most recent, is a Houghton biopower project in northwest England, just south of Liverpool. This is our largest plant, meaning it will process with 2 lines, altogether 600 tons of waste per day. Feedstock pick has a capacity of 240,000 per annum and able to treat 200,000 tons per annum. Construction is at its final stage right now. Drying out castables has just finished and the waste should be starting to be fed within March, even could be early next week. Very exciting time for us and we are pleased that it is happening. Before moving forward, a quick description of our waste treatment technologies. We mainly have three types. I already mentioned briefly before. We have a grate type incineration. We have 8 plants. Fluidized bed gasification combustion, 40 plants. Lastly, the fluidized bed gasification and melting furnace plants with 22 plants. One of the advantages CASE provides by the gasification melting plant is that only limited pre-treatment is needed. The feedstock needs to be shredded to approximately 15 centimeter by 15 centimeter, but that is almost all that is needed. This means we can take a wide range of waste streams, including residual MSW, C&I, and also fines from RDF, which otherwise would be landfilled. Experiencing in Japan, feedstock also includes water sludge, waste dug out from old landfills, and bottom ash from grape incinerators. Another main factor which makes the technology special is because of its byproducts. First, we are able to recycle metal, such as aluminium and steel, from the gasifier. The metal comes out clean and dry, so it's easy to handle for its next life. In some cases in Japan, they feed metal waste intentionally to clean it up. Also, after the gasification process, vitrified slag is produced from the melting furnace. This vitrified slag, which is a new material in Europe, is fully expected that will be given end-of-waste status under the EU Waste Framework Directive. Tests will be and are carried out in UK. Currently, technologies to make use of vitrified slag is developed in Japan, such as asphalt pavement, blocks, and so on. By reusing the vitrified slag, potential landfilling can be avoided. Just to conclude my part for the overall, we get good thermal recycling, waste flexibility with minimal pre-treatment, which leads to produce recycling materials and reduce landfill. Also accept unusual feedstock, such as fines from RDF. We do not require support fuel such as coke to be added. Lastly, this is a proven technology of more than 20 years with 22 records. Now I would like to hand over to Nii-san. He is a technical expert. He will be able to explain the details of our technology as well as a reference project. Nii-san, I will pass on to you. The floor is yours.
Thank you. All right. Thank you. And can you see my face? And I will just make a preparation of my material, so that please wait on 1 minute.
Thanks a lot. We can see you well.
Maybe you can see now. And sorry, maybe I just need to make things first to like. Can you see my screen now?
Yeah.
All right.
Yes, yes.
You can just put it on full screen.
Yes.
Perfect.
All right. Bonjour and konnichiwa. Je m'appelle Toshinori Nii of KOBELCO ECO-SOLUTIONS, Japan, in charge of international energy from waste proposals and projects. I am working from home today, comfortable with no mask alone, but apologies for without tie. And I am very much pleased and honored to have this kind of opportunity to do a presentation of our technology. I will talk about KOBELCO gasification and melting technology and plants. Since 1980s, KOBELCO had many references in fluidized bed incineration plants for MSW or sewage sludge, and developed gasification by our high-efficiency combustion know-how in 1990s. Also, KOBELCO had many references in swirl flow melting plants for sewage sludge from 1990s and integrated ash melting without external fuel into MSW sector, utilizing waste own calorific value by gasification. In the year 2000, KOBELCO launched the first fluidized bed gasification and melting plant in Japan. Since then, we accumulated our know-how and experiences through operation and maintenance of those plants in 20 years. Now the details of the process. Plant consists of waste feeding, gasification furnace, melting furnace, boiler, steam turbine and generator, flue gas treatment, and induced draft fan to keep negative system pressure. Waste feeding section, MSW, or commercial and industrial waste, is fed to gas fire continuously by waste crane, shredders, and feeders. Gas fire. Gasification furnace is cylindrical and contains sand at the bottom of the furnace. Fluidizing air is injected to sand bed in the gas fire. At the initial startup, sand is heated up by the burner to the temperature around 500 to 600 degrees Celsius. No further external fuels are required after initial startup. Waste burns by itself. No mechanical moving parts are there. Combustibles are gasified to syngas, such as hydrogen, methane, carbon monoxide, etc., and going to melting furnace with ash, tar, char from the top duct. Material recycling is achieved as well. Incombustibles and sand are withdrawn from the bottom of the gas fire. Aluminum and ferrous materials are recovered. Sand is returned to gas fire to reuse for fluidizing sand. Melting furnace, thermal recycling and material recycling are achieved as well. Melting furnace is also cylindrical with water membrane and internal castables. Additional air is injected from the top of the furnace and syngas is combusted to raise the temperature around 1250 degrees Celsius, and entrained ash is melted by itself inside swirl flow melting furnace. Melted ash is discharged from the bottom of the furnace and cooled down by the water, and the vitrified slag is certified by JIS, Japanese industrial standard, and used as roadbed construction materials, etc. Thermal recycling is achieved as shown from flue gas. Flue gas volume is very low due to low air ratio by gasification in the furnace, so the heat loss from flue gas is very small and efficiency is high. Flue gas heat is recovered by the boiler and high pressure steam is generated and electricity is produced by steam turbine generator. Now, as an unique reference, I will introduce landfill to gasification and melting. Sennan, Sendai City South Plant. We are EPC plus O&M contractor with DBO, design, build, and operation, 15 years contract. Sennan plant treats dugout waste from nearby existing ash landfill to extend landfill life. I will talk about dugout waste treatment, landfill life extension, and operation result. Photo shows our Sennan plant located northern part of Japan. Started operation from 2017. Building has one underground floor plus 6 stories with the height around 30 meters and the stack is around 60 meter height. Building area is 5,400 square meters. This table shows Sennan plant specification by our gasification and melting technology. Capacity is 100 tons per day, 2 lines. Annual throughput is around 60,000 tons, equivalent to the population of 170,000 in the area of 2 cities and 7 towns. Treated waste is mainly MSW, with small amount of wastewater sludge, bulky waste, residues from recycling center, and dugout waste. Boiler condition is 4 megapascal, 400 degrees Celsius. Flue gas treatment is by baghouse and selective catalytic reduction reactor. Generator rating is 3.2 megawatt. This slide shows Sennan plant flow sheet. Process flow is almost the same as shown minutes ago in the slide. One topic is that the classified incombustibles from gasification furnace is transferred to be recovered as additional vitrified slag in the melting furnace. The another topic is in flue gas treatment system to meet stringent local criteria. Flue gas emission criteria by local Sendai city requirement is far below from the figures by the law in Japan. Nitrogen oxide is 110 ppm by law, but 50 ppm is the local criteria in Sendai city area. That's why additionally selective catalytic reactor is installed at the downstream of baghouse. This slide shows Sennan landfill site. Digging out area and landfill area are covered as shown by transportable movable shelter. Each size is 40 meter by 50 meter and 10 meter height. And the shelter is to prevent dust dispersion. For instance, in red color area is for landfill work and blue is digging out work area. In A1 area, when landfill work is completed, shelter will be moved to A2 area for digging out work. In B1 area, when the digging out work is completed, landfill started, shelter will be moved to A2 area when landfill completed. And onwards from A2 to A3 area and from B2 to B3 area. Like this. This slide shows digging out workflow at Sennan landfill site. Landfill waste were from old great incineration bottom ash, fly ash, and residues from existing recycling center. Typical dugout waste composition analysis result is shown in this table. Majority is 70 to 80% ash, and LCB is generally quite small, even with small amount of combustible residues. Dugout waste is transported to sorting area, classified by trommel by sieve 60 mm opening. Larger one will be heading back to landfill again, while smaller one will be transferred and fed to gasifier in Sennan plant. These dugout waste have been treated by our gasification and melting plant and recovered as vitrified slags since 2017. This slide shows digging out plan at Sennan landfill site. Red dotted line shows no digging out case. Landfill started 20 years ago. As you can see, landfill area was supposed to be full and finished in 2019. Blue line shows planning for digging out case, and orange line shows actual result up to last year. By digging out work, approximately 16 years extension can be achieved, and we almost achieved as planned so far. This small drop was caused by suspension of digging out work last year as a consequence of typhoon disaster waste treatment activities. This slide shows dugout waste, co-firing ratio, etc. Blue bar shows actual dugout weight per month, and it is around 100 to 300 tons per month, depending upon yearly and monthly waste treatment plan at Sennan plant. Planned co-firing ratio was supposed to be below 5%, exactly 4.6%, as shown in red line, while actual co-firing ratio shown by orange line is good enough, around 5%. And the treated total ash ratio shown is around expectedly 10 to 15% as a result, as shown by gray line. This slide shows the operation result in 2019 to 2020. We achieved continuous 268 days operation, equivalent to around 6,500 hours to treat MSW plus dugout waste safely and stably until planned shutdown period. Okay, this is a different subject. For your information, international project scheme. In Japan, we are working as a prime EPC O&M contractor. On the contrary, in EU states, we are not familiar with local rules, so we'd like to work with experienced EPC partners in EU states. During EPC phase, we provide basic engineering for gasification and melting technology, for equipment supply, for performance guarantees. We provide erection and commissioning supervision, plus support from our Kobe Research and Development Center on demand. Operational supervision will be provided with our O&M experiences through remote service if available. Lastly, the summary and conclusion is shown. By our reference of fluidized bed gasification and melting plant, we achieved thermal recycling, high efficiency power generation, material recycling. We get recyclable materials such as aluminum, ferrous materials, and slag. Achieved continuous stable operation, reduction of final volume for disposal, and landfill life extension achieved. And just a tip of information is we can accommodate high calorific value waste up to 60 megajoule per kilogram by our gasification melting plant. And I'm pleased to conclude today's presentation that we can create sound recycling society by our fluidized bed gasification and melting technology. Throughout our business activities, we would like to continue to contribute for global and local communities with sustainable future. And as in our company vision, to keep the earth sky blue, KOBELCO ECO-SOLUTIONS, KES. Thank you very much. Merci beaucoup. ありがとうございました。
Thanks a lot to both of you. That was really, really interesting. Many thanks. Is there any question within the participants? If someone wants to start and to ask a question, do not hesitate. I have a question. So thank you for the insightful presentation. Is your technology adaptable for chemical valorization of syngas instead of energy? Did you get a question?
Nii-san, can I ask you to answer, or shall I?
Could you please repeat again?
Yes, I will repeat it. Is your technology adaptable for chemical valorization of syngas instead of direct energy valorization?
Yes. Oh, okay.
You know, for example, I don't know, production of hydrogen or like a pure gas.
Yes. You know, we have been trying to do that. You know, previously, several years ago, to have the pilot plant in France, actually. But you know, that type of activities is now not so active. And yes, as you pointed out, the most maybe the efficient way to utilize gasification is to use syngas directly to something. Maybe that's what you mean, right? So that, but it's a very long way to do that, and we are not doing these days, actually, just to concentrate on the gasification and melting or gasification and combustion plant these days, utilizing the gasification technology for a higher efficiency of the conversion.
Okay, that's very clear. Thanks.
Yeah, thank you.
So I have another question in the chat. Do you have a measure of the moisture of waste in landfill mining? Digging out, like when you dig out the waste, what's the moisture of the waste?
Moisture content is shown here, around 10%. Dugout waste composition, you can see here. This is a typical analysis result, and we use as it is.
Okay.
Because that, you know, as I said, that co-firing of dugout waste ratio is around 5%, so that doesn't affect much overall material balance for the input.
Okay, thanks a lot for your answer. Another question, so how long can your plants work before having to do some maintenance? So I know you talked about 260 days, something like that?
Yes. Is
it around that?
Yes, it's very difficult to give you the clear picture, but you know, in the maybe in terms of the availability you mentioned, maybe, and I know the European or the worldwide for the great type, they guarantee something around over 8,000 hours per year. But you know, yes, and our technology, we are very confident, but we do not much about the waste characteristic by itself, and we are not sure about the operation and maintenance skills. Upgrading is required to keep the continuous operation like in Japan, so that we are just at the very conservative position now to make the guarantee for that, so that sort of 10%, not 10%, sorry, that around say 7,700 something hours is our target at this stage. But after achieving the commissioning and operation of the reference in the UK, Naomi mentioned about the futon, and we are very much pleased to have the data analysis by our staffs and engineers, and we will make it much more proven with the European waste and with the European operators skills, so.
Okay, thanks a lot.
Yeah, and does that give you an answer? Yeah.
No, you can go on if you want to give another answer.
Yeah, that's okay. Yeah, that's all at this stage.
Okay, so I have many questions to ask. Do you have any trouble of catalyst poisoning in your SCR because of sulfur oxide? So I don't know. I think they meant RDF. Do you have? Oh no, yeah. Do you see the question? Do you have any trouble of catalyst poisoning?
Yes, like poisoning. Yeah.
Yeah.
You mean about the catalyst, right?
Yeah. Because of sulfur oxide.
Yes. Sometimes, yes. We have also the poisoning issues in Japan also, but not many. Sometimes, yes. But in such a case, we go into the root cause analysis for that, and we investigate, and we will try to find out the actual cause for the poisoning and remove the such issues to make it happen to stable operation.
I didn't really get it. Did you already identify? Did you sometimes identify that it was because of sulfur oxide? Yeah.
Yeah.
Okay.
That's yes. Plant by plant. Yes.
Okay. Once the dugout waste is converted into syngas, what is the LHV of it?
You're talking about the after co-firing with the dugout waste, the syngas calorific value, you mean?
Yeah, exactly.
Yes. Actually, that does not affect much. As I said, that the combustibles within the range to have the syngas calorific value over 2 megajoule per normal cubic meter. Maybe such is the criteria for the calorific value of syngas, I believe, in the EU states as well. And even the co-firing of dugout waste, in operation, and we do not see any difference, any much difference in the operation for the gasification and combustion.
You use all landfill waste, and sorry, I'm just reading before the question. Okay, so that's a question. You use all landfill waste, and you only use a material that is smaller than 60 millimeters. So do you burn dangerous waste? It's not really burning. Do you classify? Do you have dangerous waste into the classifier?
No.
That are
No.
such as, for example, batteries or etc.
No. Better not to put in the hazardous stuffs in the system, and that type of waste should be treated by other means. I mean.
Yeah, sure.
Yes, and sometimes, and actually, and in Japan also, some small amount of the batteries will be put in, but very small amount is okay. But our treatment plant is good for the general waste, not the hazardous waste.
Yeah.
Is it okay?
The batteries
for the
shouldn't
answer?
be in the landfill in the first case.
Yes. Yeah.
So everybody's saying thank you. I have another question. Is there any kind of pollutant that is not compatible with your process?
Pollutant?
Yeah, so in the feedstock, I suppose.
For the emission, you mean? Emission? You mean in the flue gas?
No, I think it's the pollutants in the feedstock waste. I think so. I think that's
pollutant in the feedstock.
The participants
means that maybe the sort of the very dangerous something. You mean?
Yeah, I think that's the question. But the participant can ask directly his question if he wants to, so it would be easier to explain his question. Okay.
Yeah, excuse me. Yeah, I think that was my question. Yeah, I was asking about this pollutants that you can find in the feedstock that could damage your system, or for example, we talked earlier about the sulfur poisoning. But maybe there are other compounds that could damage the system.
Yes. Good point. Like sulfur or the chlorine. That we have the limitation, say like 1% at the feedstock, and we specified, for the feedstock specification, for the limitation or the criteria for the sulfur and chloride, to avoid the unnecessary damage into the system or equipment or boilers, especially. Okay. Does that answer your question?
Thanks, Sylvain. Okay. Yeah, I think so. Okay, so what kind of waste? It's the question about the specifications on the quality of feedstock waste that can enter into your system again. Like, do you have specifications?
Yes.
On the quality.
Criteria, yes, we have, yes.
So, for example, can you give us some elements? So, not about the composition.
You told us about chlorine, yeah, 1% or. Chlorine, 1%, sulfur 1%.
Yeah. Okay.
Yeah.
The moisture, for example,
moisture 30 to 40, yeah, around.
Okay.
Yeah.
Thanks a lot. What minimum capacity do you propose, like for a pilot project or for an industrial project? And which
Yes.
capex, which investment will be for
Yeah,
certain capacity?
it's very hard to answer about the capex or something, but you know, the in the early 2000, we provide the like one line is 30 tons per day, meaning that 10,000 tons per annum per one line is the minimum. But no power generation can be done. So that if you need some like power generation or heat usage, say like above 70 to 80 tons per day per one line is required, better to have. So that means that say over 25,000 tons per annum level is required.
Okay.
If you need some sort of a provision for the combined heat and power.
So 80. So 30 would be the minimum without energy production, and 80 would be okay. The minimum if you want to.
Tons per day, yes, yes, that's right, yes.
Okay, very clear, thank you. And yes, about the capex, it's always a bit difficult to answer, but it's true that it's
very
always
difficult, yes.
a question that comes. If you have some examples, some elements on that. But I suppose the participants can also contact you afterwards to ask questions by emails. Yeah.
Yes.
Okay.
Of course.
Thanks.
Project by project, better. Yeah.
Yeah. It's better to enter in a particular situation on the costs.
That's right.
Otherwise,
That's right, yes.
it doesn't really mean anything. So another question. So thank you for the interesting presentation. About the bottom ash recover in the FB furnace that is then vitrified. What is the temperature to achieve the vitrification of the material? Does it need a further treatment like maturation, carbonation, etc., as traditional slag?
Maybe the question is that in the melting furnace, the temperature, right? Yes, it's as I said that to melt the ash is required 1,250 degrees Celsius and over required. Yeah.
The other question was, does it need a further treatment like maturation, carbonation, as it's done for traditional slag?
No required. No.
No further treatment. Okay.
Yeah. No further treatment required.
Could you imagine? Could we imagine your system using biomass such as wood waste?
Yes.
Yeah.
Of course, yes.
Have you done it before?
Yes, and we have the actually a biomass-based power plant in Japan by ourselves.
Okay.
You know, to generate the electricity 7 megawatt, utilizing the local wood chips and you know, like to produce power to the local community in Japan.
Is it traditional combustion or gasification in this case?
Gasification and combustion, which Naomi explained in the in her slide. You know, like this center one, fluidized bed gasification and combustion furnace can be used for the waste as well as biomass.
Okay. Are you managing your smoke How are you managing your smoke treatments? Do you use chemical components?
What did you say again, please?
How do you manage the treatment of the smokes? The waste smoke, yeah. And do you use chemical components, etc.?
Smoke means from the stack or
exhaust gas.
Exhaust gas.
Exhaust gas, yes.
Yeah, it would be exhaust gas would be better.
exhaust gas treatment is like this, bag filters and let's say sometimes a catalytic reactor here required. Yes. And you're talking about the moisture or smoke, you mean, from the stack, or I cannot catch the meaning of the question.
Sorry, what did you say?
I could not catch the meaning of the question.
It's only like, what kind of technologies do you use to treat the exhaust gas?
Yes, of course, yes. For the injection of the activated carbon or lime or the sodium carbonate, ammonia, yes, we are using to treat the flue gas to discharge into the air, clean air, right? So that we need to use the chemicals, of course.
Okay, thanks.
Yeah.
Yeah, another question about the investment. It always comes back. For example, could you give us an idea of the required investment for the reference you talked about? The one, the one in Senan, or is it confidential? Like, you can't talk about it?
Yeah. Better not on this session, maybe.
Okay.
Because
okay.
as you know, that in Japan there is a very strict regulations and for the earthquake especially, and building cost, like a civil cost, is very high, right? So that I better not talk about such a thing, because that in the European continent, no earthquake there. Yeah, so that
we
can, yeah, and so that we can have a discussion later on for project by project basis.
Okay, noted. And everyone will have your contacts so they can ask this kind of questions.
Yes. Through Naomi-san, yes, please.
So I was surprised. It's another question. I was surprised of the fact that you do not separate the fine part of the waste in the gasifier. Do you have any problem of clogging your combustion air distribution in the bottom parts of the gasifier?
No. Talking about the injection of the air into this type, you mean here, fluidizing air, continuously fed to the sand bed, and sometimes if the operation is wrong, as temperature goes up and sand is sintered, like a clogging, yes. So that especially in the first plant in the overseas, we need to be very careful about the skills of the operation, and if that is from the automatic circuit by manual, so that we need to be very careful about that for the control group.
Okay, thanks.
Sometimes, yes. Clogging happen in here, big amount of the cluster there, or the long steel wires, clogging here, accumulated. Sometimes, yes.
So it's also a maintenance issue from time to time.
Yeah, that's right.
Okay.
Yes.
Another question: the European RDF to enter the KOBELCO waste technology, did it need to further remove inert waste? Okay. To use RDF in the KOBELCO waste technology, do you need to remove inert waste? I have always heard that Japanese normal MSW, so municipal solid waste, has lower inert. such as glass,
Yeah.
ceramics, stones, etc. Content than French or European.
Yeah, maybe it is very clear that I just mentioned about the maximum caloric value here, 16, but minimum should be over 8 megajoule per kilogram. That means that if you have too much inert in the fuel supply, we can't theoretically to make it happen for gasification, so that the minimum should be over 8 megajoule per kilogram. So that to meet such a criteria in the input, you need to control the amount for the inert. Make sense? Hello? It's okay?
Adeline, you're on mute.
Oh, sorry, I forgot to turn on my my microphone. Yes, it was really clear. Thank you. What about the OPEX costs regarding the exhaust gas treatment, especially
Yes.
if you have to achieve the 50 ppm NOx that you told us about?
Mm-hmm. Yes, you know that the ammonia injection or the required, yes. So that in any case, the figures is important for the criteria, yes. And if you need further reduction in the NOx, say here, I can't give you the exact figures, but depends on this criteria. We need to talk about for the OPEX also, for the amount of the chemicals needed.
Okay.
Yeah.
No problem. So what is the global efficiency of the Senan plant?
Overall efficiency in Japan is not a very good one, but in the UK's or EU, like waste and the regulations, say like over 25%.
Sorry?
Or overall 25% to 30. Maybe it's very dare to say, but 25 to 28% overall efficiency can be achieved.
Oh yeah, I had another question from someone who's not here today but wanting to know. So he's asking, what is the difference between KOBELCO and other Japanese solutions? Sorry. First, I have the efficiency you were talking about was the electrical efficiency. Is that right? Electric production, or is it really the overall?
If he's talking about the gasification technology only, that they are using the carbon additives, and we do not use carbon additives. That's a very big difference. Well, in relation to the Japanese other gasification technology, they use cokes. Yeah. And the calculation method is very much different, I believe, so that it's not appropriate to compare the efficiency with or without carbon additives, I think.
So yeah, so you don't use it, so it can seem lower than other technology that are using fossil.
That's right.
Yeah. Okay, yeah. Thank you. What is the difference between KOBELCO solutions and other Japanese classification solutions, such as the Ebara, the Nippon Steel, JFE, etc.? What is your specificity, I would say?
Yes, so that as I said, the two big Japanese companies are using carbon additives, and the other one does not use carbon, but that is a very different from the conception. They have the internal heat recovery pipeline in this furnace, and they sometimes have the blockage problem or something. And as I said, in our gasification furnace, no mechanical moving part or no internal pipe, or so we proudly say that our system is very robust, very simple, I think, comparing to the other technology supplier in Japan.
Okay, thanks a lot.
Yeah.
Okay, so I have the participant that asked the question about the quality of the waste didn't really understand your answers. So could you maybe summarize the main I would say specificities, characteristics of the feedstock that can be used in your gasifiers? Because you told me what I noted is you told me about the maximum chloride and sulfur compounds of 1%, I think, the moisture. What else could you say? How maybe about the preparation of the feedstock before gasification, etc. What must you do to prepare a feedstock to go into your gasifier, basically?
Yes, and Nami-san mentioned about the size of the after crushing, or the in the crusher to be fed to the gasifier, because of the fluidizing activity inside required, right? So that the fuel should be shredded into pieces, say 6 inches, 150 mil. Yeah. So that that is a very big difference from the others, To make a good fluidizing activities and a good efficiency in the gasification, we require to be shredded for the fuel.
And about for example, what's before that? What sorting specificities do you have for the waste?
Yes, sorting is sort of the depends on the requirement for recycling, I think. So that that should be done, of course, to meet with the future criteria, so that you need to remove. Maybe better to remove the plastics here, or the cans and bottles, first. But theoretically, some sorting should be done, but we can put it in here, and after we have the shredder here, so that we can accommodate, but please do not put the hazardous one, or the a bowling ball. No bowling ball can be shredded, so that type of thing should be sorted out. And a very bed mat, they have the many springs there, and we cannot accommodate such a waste, large bulky stuffs. It makes sense to answer?
Yeah, it makes sense. I don't know if the person who asked is okay with this answer, or if someone wants to speak and ask this question. For me, it was clear. I think it's clear. Thanks a lot. I think it's okay. Okay, so I think I'm good with the questions. Is there anyone who wants to talk and ask his question? Okay. Maybe a final question still about the cost. Maybe this one you can answer it easily. What is the cost of the waste, the raw waste that you get, or are you paid to treat it? What is the mechanism with that?
Talking about the Japanese way, or
Yeah, in the Japanese situation.
in the Japanese situation, no gate fee.
No gate fee. Okay.
Yeah, because that all the responsibilities in the municipality, and citizens pay tax for that, including the sort of a gate fee. But no, but last 5 to 10 years, we need to pay each this type of a bag to wrap the waste from the household, say 10 cents, 20 cents, depends on the size, right? So citizens should pay to the beer bag, this type of bag,
Yeah.
and the tax as a citizen. That's all. And the municipality manage afterwards, including this type of, all the administration for the CapEx and OpEx, including the power selling price and gate fees.
That's very clear. I'm done with the questions. If anyone wants to ask a last question, please feel free to open your mic. Okay, well, thank you very much to both of you and the old KOBELCO teams. We're really. I have a last question. Any problem of corrosion on the superheater? Do you have any problem of corrosion on the superheater in your system? It will be the last question.
What? Please say it again.
A corrosion problem on the superheater.
Corrosion problem. Yes, sometimes happens. Yes, for the higher temperature, and depends on the chlorine. Yes, and the accumulation of the dust.
Yeah.
And each time we need to make a root cause analysis again. To make it improve. We overcome such issues, corrosion problem also during the course of operation and maintenance.
Yeah. Okay.
Yeah.
You verify it at every maintenance stop.
Yeah, that's right. Yes.
Okay. Well, thank you very, very much. So the video will be available, and I will be sending your email addresses so the participant can ask your questions directly. Okay.
All right. Yes.
Many thanks. Everybody's saying thank you in the chat. It was really interesting. Thank you very much. Talk to you soon.
Thank you very much.
Thank you very much.
Merci beaucoup.
Have a nice day. Bye bye. Merci.
You too. Yeah, thank you.